Welcome to Homework Lib.
In this problem, we're going to talk about a particle in a three-dimensional box. So let's consider that we have this box here, and let's assume that this box is a cube, such that the length of the side of the box is L. And let's say we have a particle trapped inside this box, so it's confined to move inside the walls of the box. And at the walls, the potential at the walls is equal to infinity. In that case, the wave function psi of x, y, and z of the particle is equal to a constant a times the sine of n x pi x over L times the sine of n y pi y over L times the sine of n z pi z over L. Okay. Um, and a in this case is just a normalization constant, and it's equal to 2 over L to the 3 halves. Okay, you can find this by imposing that the integral of the absolute value of the wave function squared over all space. Here I'm going to write 3 d3r is equal to 1. Okay, also remember that the probability of finding the particle in a certain range, let's say between x0 and x prime, y0 and y prime, z0 and z prime, is equal to the integral, the triple integral, over x, y, and z of the absolute value of the wave function squared over all space. I'm sorry, over the this particular region of the space here. And what we have in our problem is a particle inside a box that has a side L, and we have to consider the region of the box between 0 and L over 4. So x is between 0 and L over 4. Okay, there's an equal sign here. Y is between 0 and L over 4, and z is between 0 and L over 4. And in question A, we have to find what is the portion of the volume that is occupied by this region of the box. Um, so consider a box that instead of having a length L, has a length L over 4. In that case, the volume of the box is equal to L over 4 cubed. So this is L cubed over 64. And the original volume, so this is the volume if the box had a length L over 4, the original volume is L cubed. So the new volume divided by the old one is equal to 1 over 64. And this is 0.0156. This is the answer to our first problem. Then in question B, we have to calculate what is the probability that the particle will be in this region for the ground state. There is when nx is equal to 1, and y is equal to 1, and then z is equal to 1. Well, remember that the wave function is 2 over L cubed, actually to the 3 halves, times the sine of nx, which is 1, times pi x over L, sine of pi y over L, times sine of pi z over L. Uh, then we need to integrate this over all space, and notice that the integral of the actually of the square of this, right, over this particular region of the space, and so this is between. I'm sorry. Let me write it like this: 0 and L over 4, 0 and L over 4, 0 and L over 4 of dx dy dz. So this is the integral between 0 and L over 4 um, times the integral of 0 between 0 and L over 4 times the integral between 0 and L over 4 of 2 over L to the third times sine squared of pi x over L sine squared of pi y over L sine squared of pi z over L. Um, Actually, I should multiply this all by dx dy dz. So this is 2 over L to the third times the integral from 0 to L over 4 of sine squared of pi x over L dx. And notice that then I'm going to multiply by a very similar term, substituting y by x, and then by a very similar term, substituting z by x. All these terms will end up being the same. They have the same value. So I'm just going to uh, take this to the cube. So what I need to do is to integrate sine squared of pi x over L between 0 and L over 4. Now remember that the sine squared of x is 1/2 times 1 minus cosine of 2x. So this is 1/2 of the integral of between 0 and L over 4 of 1 minus the cosine of 2 pi x over L dx. This is 1/2 times L over 4 minus 1 over 2 pi divided by L times sine of 2 pi x over L. And this last term should be calculated between 0 and L over 4. When x is equal to 0, the sign will be 0. When x is equal to L over 4, this is the sine of pi over 2, so that's 1. So this is 1/2 of L over 4 minus L over 2 pi. So this is equal to 1/8, L over 8 actually, minus L over 4 pi. So P is equal to 2 over L to the third times L over 8 minus L over 4 pi to the third. And this probability is equal to 7.5 times 10 to the minus 4. Then in question then in question C, we have to do the same, but now considering that n x is 2, and y is 1, and nz is 1. So now our probability changes just a little bit. It's still 2 over L to the third, but then we integrate from 0 to L over 4 in sine of 2 pi x over L, and then the other 2 are the same. So we have the integral between 0 and L over 4 of sine of pi y over L, I'm sorry, times the integral between 0 and L over 4 of sine of z over L. Now notice that these two values here, we've already calculated it. They are equal to 1 L over 8 minus L divided by 4 pi. So this is actually equal to 2L cubed times L over 8 minus L divided by 4 pi squared times the integral of sine of 2 pi x over L dx from 0 to L over 4. So this is 2 over L times 1 eighth minus 1 divided by 4 pi squared times this integral here. Let's calculate what this integral is. So we know that this is the integral, is 1/2 of the integral of 1 minus cosine of 2 times the argument, so that's 4 pi x divided by L dx. So this is 2 over L 1/8 minus 1 divided by 4 pi squared times 1/2 times L over 4 minus L over 4 pi times the sine of 4 pi x over L from 0 to L over 4. This last term cancels out. Notice that when x is L over 4, the sign is 0 because it's the sine of pi. And when x is equal to 0, the sign must also be 0. So this is um, just 2 over L times 1/8 minus 1 divided by 4 pi squared times L over 8. So this is equal to 2.06 times 10 to the minus 3. And this concludes our exercise.